Hello and welcome to this video in the measurement series. This one is dealing with the surface area of pyramids and cones. Please note the information from this video is coming from the Cambridge Year 11 Standard Mathematics textbook for New South Wales. So you can see on the screen at the moment there is just a little bit of information from that textbook about pyramids, particularly square pyramids, and you can see there that we have the square pyramid. So we have a formula for the square pyramid, which is this bit that we are going to be using. So we want the side length of the base, which is this bit around here. This is our side length. And then the slant height of each triangular face, or of the triangular face, because they are all the same in a square pyramid, is this bit right here. So there's our slant height there. Okay, so this is what we're going to use to solve our problems involving square pyramids. So here's our first example. We have the square pyramid has a base with a side length of 6 centimeters and a slant height of 4 centimeters. And we want this surface area of this square pyramid. So the first thing that we can do is we can actually break this out as we've done previously and draw up a net. So if we were to break up this pyramid, we would have a square base, and then we would have the triangles coming off of it. Now, if we were to draw this properly, every triangle would be the exact same size, and the square would be a perfect square if we were using a ruler. Now, in the net, we can put in that these sides here are the same, and they are all 6 centimeters as per the diagram. And our slant height, which is this perpendicular height in the triangle, the slant height, which is the perpendicular height of the triangle, is 4 centimeters. So these are the bits and pieces of information that we need to be able to successfully answer this question. Next task that we do is we are going to put together the formula that we saw before and the information that we have about our pyramid. So let's start with our formula. So SA for surface area, the side squared plus 4 times a half SL. Okay, so there's our formula there. You can see that it matches the one that I have highlighted up the top. Now the reason why there is 4 lots of the half SL, so SL being the area of the triangle, so it matches up with BH, or base height, base times height, matches up to the surface area of a single triangle, and we have 4 of those, which is why it's times 4. So let's go back to our question. So next, let's substitute in what we're going to be doing. So here, the side length is 6, so it's 6 squared, and then we're going to add that to 4 lots of a half times this side, which is 6, times the slant height, which is 4. Now we can just type that straight into our calculators, just as is. Saves us a couple of lines of working there if we do that, and we get 84 centimeters squared. Make sure when you're doing area that you are using that centimeters squared. Now, as I said before, this video isn't just about pyramids. This one's also for cones. So let's look at the cones now. And as you can see there, we have some information about cones. Cones being basically a ice cream cone, where you get that cone from a Rich's hat, something similar to that shape. We've got our circle at the bottom, and then we've got everything coming up from that to a point. So the area here is the circular base, that is pi r squared, and the curved surface, which is pi rl. So that is the radius of that circular base times pi times the slant height for that second part of the formula. So the formula for this one, we'll chuck it up here in green. Alright, so surface area equals pi r squared. Alright, so there's our surface area for that circle at the bottom, plus pi rl. So that is the other part of the cone, which is the curved surface. Okay, so we have pi r squared, which is the circle base, the circular base, and then we have pi rl, which is our curved surface. Okay, so that's the two bits that we need to worry about there, and you can see where we've gotten all that information from. Now let's look at our example. Our example here, we've got two things to find. We have a cone with a radius of 6 centimeters and a slant height, or a perpendicular height rather. A perpendicular height, so straight up from the bottom to the point, to the apex, is 14.4. So the first thing we need to do is we need to find the slant height. So this is the height we're looking for over here. So essentially, for question A, we're looking for the hypotenuse of the triangle that is formed by the perpendicular height and the radius. So we've really got a triangle that looks kind of like this. Nice little right angled triangle. This side here being 6 centimeters and this one over here being 14.4 centimeters. And here is L, or the slant height. Okay, so let's set this up just like Pythagoras. Especially when you're trying to find a long side, I like to put the thing that we're looking for on the left and the thing that we're going to work with on the right. That's just how I do it. You can do it the other way if you would like to. Now, obviously, it's not going to be a C, it's going to be an L. So L squared is going to be 6 squared. I'm going to add that to 14.4 squared. Okay. Now, obviously, that's going to get us L squared. We don't want L squared, we want just L. So we find the square root of these two bits, and that we can just chuck into our calculator nice and easy. Gets us approximately 15.6 centimeters. So there's our slant height, 15.6 centimeters. That's what we're going to use for B. B being the surface area of the cone itself. Okay, so let's remember that formula that we were shown before. Surface area being pi r squared for the circular base. Add that to pi rl, which is the curved surface. So let's set this up. We're going to substitute in. We've got 6 squared for the radius, plus pi times 6 times, and this one is 15.6, which is what we got from the previous question, So A, so part A, we're going to carry that down. And chuck all that through the calculator. Gets us 407.1504, and it continues on, obviously, because pi itself is an irrational number and goes on forever. So we're going to round that off to the nearest square centimetre, which is what we've been asked for over here. Okay, nearest square centimetre, so nearest whole number will do us just fine, which is 407 centimetres squared. Don't forget to put that squared when you're using area. Okay, hopefully that has helped you work out the area of a pyramid and the area of a cone, or the surface area of those shapes or those 3D objects, and we'll see you in the next video.